MRI Image Quality. The image's quality depend on 1. Resolution, matrix, field of view, FOV, slice thickness 2. Signal to noise ratio 3. Contrast 4. Artifact resolution. The resolution is the size of the individual pixel, 2D, or voxel, 3D. The smaller the pixel or voxel, the greater the resolution. It is intimately related to the field of view, the matrix size and the slice thickness as shown in the equation below. Voxel volume equals field of view, matrix, x slice thickness. Matrix. The matrix size is the number of pixels in the images. Increasing the matrix size will increase the number of pixels in the image, but, as they are still within the same field of view, they will be smaller. Increasing the matrix size increases spatial resolution. Smaller pixels, voxels means better detail. Decreases signal. There are fewer photons per voxel, so the signal is less. Increases scan time. More voxels need to be acquired. Note this is only in the phase encoding direction, as each voxel requires a new signal, i.e. more voxels means more signals need to be created. Field of view. The field of view, FOV, determines the size of the area to be imaged. A larger field of view means a larger area image. The matrix size remains the same, and so, to fill up a larger area, the voxel becomes larger. Increasing the FOV increases the signal. A larger voxel means more signal received per voxel. Lower resolution. The voxels become larger, increased viewing area. Slice thickness. Increasing the slice thickness increases the signal, decreases the resolution, increases the partial volume effect, gives larger object coverage. Slice gap. The slice gap is the amount of space between slices. It is measured as a percentage of the slice thickness. The slice gap is the gap between the peaks of these curves. We want to minimize the amount of space between each slice to prevent sections being missed. Increased slice gap. Less crosstalk, increased coverage. Slices placed further apart and, therefore, cover a larger area. Signal to noise ratio. To get a useful picture, the amount of signal from the thing being imaged should be greater than the noise. A higher SNR means a better and more useful image, more signal than there is noise. The greater the size of the voxel, pixel, the more signal there is per point in the image, improving the SNR. However, a greater voxel, pixel means each point in the image is larger and the resolution is lower. Number of acquisitions. Another way to improve the signal is to scan the same area several times. This is determined by the number of acquisitions, number of signal averages, NEX, NSA. Each acquisition fills K space. We can repeat the number of acquisitions and then average the signals to create the image, thus collecting more signal per slice imaged. Increasing NEX increases signal, however, the signal is only increased by square root NEX. Less noise, fewer artifacts due to signal averaging, increased scan time. Doubling the NEX doubles the scan time. Tips summary. Voxel volume equals field of view, matrix, x slice thickness. Increasing the matrix size. Increases spatial resolution, decreases signal, increases scan time. Increasing the FOV. Increases the signal, lower resolution, increased viewing area. Increasing the slice thickness. Increases the signal, decreases the resolution, increases the partial volume effect, gives larger object coverage. Increased slice gap. Less crosstalk, increased coverage. Increasing NEX. Increases signal, less noise, fewer artifacts due to signal averaging, increased scan time. To improve the SNR. Increase NEX, lower resolution, thicker slices, larger FOV,